Hello students, today we are discussing about a few topics related to set theory. In our previous classes, we have learned what is set, what are the types of sets. Now, a few important points we have which we need to discuss and we need to remember in our mind. Now, let us see what are the points we need to remember and why these points are important. Now, the first point here, in roster form, the order in which the elements are listed is immaterial. As I told you, the set can be represented in two ways. One is list form or roster form. The second one is set builder form or rule form. Here I am talking about list form, means roster form. What they are given there? The order in which the elements are listed is immaterial. So, representing the elements in the set, we no need to follow any order. You can follow any kind of order. The result gives the same answer. You will get the same result. For example, if I ask a student to write vowels in English alphabet, he might have written the answer set A is equal to A, E, I, O, U. If I ask another student to write the same, he might have written that answer A, I, O, E, U. The same question if I ask some other student, he might have written the answer U, O, I, E, E. Now, three students are given three different answers. What is the first answer? A, E, I, O, U. The second student gave the answer A, I, O, E, U. The third student gave the answer U, O, I, E, A. If you observe the three, now I can say that all the three answers are correct. Why all the three answers are correct? Means, if you observe those three sets, here the set you have the same elements, here the set you have same elements, here also you have the same elements. What is the difference we are finding? The order. Here we have a proper order A, E, I, O, U, but these two are not following a proper order. So irrespective of the order, all the three sets are having same elements. All the three sets you have A, all the three sets you have E, all the three sets you have I, all the three sets you have O, and all the three sets you have U. So set A, set B, set C, all the three sets are having same elements. So here the order of the elements in roster form is immaterial. Immaterial in the sense not an important. You can follow any kind of order. Nothing is wrong. Now the second point. This is about first point. Now we are discussing about the second point. What is given the second point? It may be noted that while writing the set in roster form, an element is not generally repeated. Again we are discussing about roster form. What we are having roster form? We have the list of elements. What they are telling? The elements are not generally repeated. So repeated elements we don't need to write. We need to write repeated elements in roster form. Means, for example, here I have a question for you. Example, set A is equal to x such that x is a letter in the word Chinmaya. We have a set A. What is this set A we are representing? X such that x is a letter in the word Chinmaya. Now, which form I have given the set? Here the set is in the form of set builder form. It is there in which form? Set builder form or rule form. Now this set builder form I need to convert in which form? Roster form. Now let us see how to convert it. What is the question they have given? X is a letter in the word Chinmaya. What are the letters we have? First here C, H, I, N, M, A, Y, A, Chinmaya. First letter, what is the first letter we have? C. We can write here, comma. Next letter, H. I can write. Next letter, I can write. Next letter, N. I can write. Next letter, M. I can write. Next letter, A. I can write. Next letter, Y. I can write. What is the next letter? A. A already we have written, so we don't need to write about A. So these are the letters we have in the word Chinmaya. C-H-I-N-M-A-Y-A. Here the letter A is repeated twice, but we have taken only once. You don't need to write 2 times or 3 times. That is the point given here. So in roster form, an element is not generally repeated. That is, all the elements are taken as distinct. Distinct means different. So whatever the elements we have in a roster form, all the elements must be different, not in the same. Next, the third point. What is the third point? All infinite sets cannot be described in the roster form. All infinite sets. If I ask set of rational numbers or set of real numbers, so we cannot describe in the roster form, because usually we mention what? 1, 2, 3, 4 and so on infinity. Means we don't know what about infinity. We cannot define properly. We are unable to represent all the numbers in that number system. That is about point number 3. Now point number 4. All equal sets. All equal sets are equivalent. All equal sets are equivalent sets, but converse is not true. In our previous class, we had a discussion about what are the equal sets and what are the equivalent sets. I told you for equal sets should follow 2 conditions. Condition number 1, number of elements should be same. Condition number 2, elements are also must be same. Number of elements and element both must be same. Then those sets are called equal sets. Equivalent sets. Equivalent sets means what I said? Same number of elements but not same elements. Same number of elements but not same elements. For example, to understand that point, I have given set A 1, 2, 3, 4. Set B we have 1, 4, 3, 2. Once if you observe, set A, number of elements in set A, I have 4. Number of elements in set B, I have 4. Now both sets are having same number of elements. I can call their equivalent sets. Now again, when we compare the elements 1, 1, 2, 2, 3, 3, 4, 4, both sets are having same elements, so that I can say it is equal sets. So when the number of elements are same, we can say these two sets are equivalent sets. When the elements are also same, we can say that they are equal sets. So all equal sets are equivalent sets. All equal sets are equivalent sets. But converse is not true. Means all equivalent sets are not equal sets. Equal sets are always equivalent. Equivalent sets are not equal. All equal sets are equivalent because same number of elements we have. But equivalent sets are not equal sets. Here A and B, I can say that equal sets, and also I can say that equivalent sets. Whereas here I can say that A is equal to 1, 2, 3, 4. B is equal to A, B, C, D. Here, number of elements in A, I have 4 elements. Number of elements in B also I have 4 elements. Now what I can say about these two sets? Both sets are having same number of elements, so they are called equivalent sets. Now when we compare the elements are different, so I can't call their equal sets. These sets are only equivalent sets. These sets are nothing but equal sets. Now all these equal sets are equivalent, but equivalent sets are not equal sets. That is about point number 4. These 4 points just we have to keep it in our mind wherever we use. Wherever these points are necessary, definitely we recall those points. According to that, we can write it. Next, our concept is we go for subsets. Once again, subset. Sub means part of a set. Subset means part of a set. As I told you, our classroom is a part of a school. Means our classroom is a subset to a school. When school is a bigger one, our classroom is nothing but part of a school. So that it is a subset. 10th class is also a part of a school. 12th class is also part of a school. These all are nothing but subparts to a school. Similarly, subset, as I told you, all natural numbers are subset to whole numbers. All whole numbers are subset to integers. All integers are subset to rational numbers. All rational numbers are subset to real numbers. So the biggest number system which we have, real numbers. All numbers are part of a real number. So natural numbers are part of a real numbers. Whole numbers are part of a real numbers. Integers are part of a real numbers. Rational numbers are part of a real numbers. I told you that this is the symbol we call subset. This is the symbol for subset. Now, I have set A. Set A consisting of 1 and 2. I have only 2 elements. How many subsets do you have for the set A? That is my question. How many subsets do you have for the set A? How can we say that? set A is equal to 1 comma 2. We have only two elements. Now I want to find subsets of this set A. Now let us see subsets of A. Now what are the subsets of A we have? You remember one thing, for any set except non-empty set, for any non-empty set, we have minimum two subsets. What are they? Means empty set and the set itself. For every non-empty set, we have minimum two subsets. What are they? Pi is a subset for every set. This is one point we need to remember. The second point, every set itself, it is a subset. These 2 points we need to remember while writing subsets. Pi is a subset for every set. You can take any set. Definitely pi is a subset. And the second point, for every set itself it is a subset. For every set itself it is a subset. So definitely we have two sets for every non-empty set. Like in numbers, we have prime numbers and composite numbers. Prime numbers and composite numbers. When we have taken 2, for 2 we have two factors. One is a factor for every number and a number itself it is a factor. Similarly, when we take 3, for 3 also we have two factors. What are they? One is a factor for every number and number itself it is a factor. When we go for 5, now for 5 we have 1, 5. 1 is a factor for every number, 5 itself it is a factor. These are nothing but called prime numbers. How 1 is a factor for every number, pi is a subset for every set. How every number itself it is a factor, every set itself it is a subset. Almost every concept which is interlinked with our numbers. So in numbers we have 1 is a factor for every number and every number itself it is a factor. In the same way, in set theory also we have pi means empty set is a subset for every set. Every set itself it is a subset. So for every set we have minimum two subsets. For every non-empty set we have two subsets. Minimum of two subsets we have. Now you observe. Now I am talking about set A. Now for set A, pi is a subset and set A itself it is a subset. Now I have 2. Now still do you have anything? Yes, we have set 1, set 2. Individually you write one element. How many elements we have? 2 elements, right? Individually. 1 alone as a set, 2 alone as a set. Now see, it is a part of this set and 2 it is also part of a set. Don't write simply 1 comma 2. Don't write simply 1 comma 2. When we write 1 comma 2, they are not sets, they are just numbers. When we keep within the flower brackets, then only they are said to be sets. You know very well. Here our concept is what? Subset, so that you should write individual. So element 1 and element 2. Now total how many subsets do you have? 1, 2, 3, 4. How many subsets we have? Number of subsets of A is equal to 4. How many subsets we have, Nana? 4 subsets. This is about set A. So where set A we are having 1 and 2 elements. Then how many subsets are you getting? 4 subsets you are getting. What are they in the sets? Pi. By default it is a subset. Set itself it is a subset. And individual elements we need to take. One is one individual set. 2 is another individual set. So that I have total 4 subsets. Now let us see one more example for you to understand more about subsets concept. If I have taken set B is equal to A comma B comma C. How many elements do you have? 3 elements. Now let us see how many subsets we get. Now number of subsets of B. First we talk about subsets of B, then we talk about number of subsets of B. Subsets of B. By default we know 2 subsets. What are they? Pi is one subset, set itself it is a subset. Let us write first. Pi and set B I have. 2 sets I have. Now still, as I told you in our previous example, list out every individual element. First we have to take individual elements as a set. What is the first element we have? A. Let us consider it is a subset. Next B. Let us consider it is a subset. C. Let us consider it is a subset. Now individual elements are over. Next we need to go for combination. Means two elements. First we consider these 2 elements. A comma B. Next we consider A comma C. Next we consider B comma C. So first we are taking individual elements. Next we are taking combination of 2 elements. After 2, the combination we have to take combination of 3 elements. Combination of 3 elements is ABC, means the set itself. Now set A, it is a part of this set. Set B, it is also part of this set. Set C, it is also part of this set. Set A comma B, it is also part of this. Set A comma C, it is also part of this. Set B comma C, it is also part of this set. Now finally, how many subsets do you have here? 1, 2, 3, 4, 5, 6, 7 and 8. I have total 8 number of subsets. So number of subsets of B is equal to 8. When we have 2 elements, we have 4 subsets. When we have 3 elements, we have 8 subsets. Now let us see when we have only 1 element. When we have only 1 element. For example, set C is having only the A. Now, what are the subsets we have here? Subsets are pi and the set itself. How many subsets do we have? Only 2 subsets we have. How many subsets do we have? 2 subsets. If you have an empty set, D is equal to empty set means pi. Now tell me, how many subsets do we have for pi? Like in numbers 1. Now what are the factors of 1? The factors of 1 are itself. You have only 1 factor. That's why 1 is called neither prime nor composite. Prime number, you should have minimum 2 factors. Composite number, you should have more than 2 factors. But 1 is having only 1 factor. That's why it is named as neither prime nor composite. Now similarly, empty set. For empty set, how many subsets do we have? Means only 1 subset. What is the subset for him? Subset is pi, means only 1. I have only 1 subset. Only 1 subset. Why we are discussing all these means? Here we have a formula. We have a formula for this. When we have empty set, how many subsets do we have? Only one subset we have. When we have one element, singleton set, how many subsets do we have? Two subsets. When we have three elements, how many subsets do we have? 8 elements. In our previous example, we have two elements. How many subsets do we have? 4 subsets we have. Now for this, now I will give a formula. So this is the way to find the subsets. Now we come to know what is the formula for finding number of subsets. N of A is equal to 0. N of A is equal to 0 means case 1. If set A is equal to pi, set A is equal to pi, empty set. Number of elements in A is equal to 0. That implies number of subsets is equal to 1. Now the second case, when set B is equal to, let us have element A, means I have only one element, means number of elements in B is equal to 1. Number of subsets is equal to 2 subsets I have. Here also let us consider A. Here also let us consider A. Now the third one, if the set A is having 2 elements A comma B, so number of elements in set A, 2 elements, number of subsets is equal to 4. Now the fourth condition, set A is having A comma B comma C, 3 elements I have. Now N of A means the number of elements in A is equal to 3. Number of subsets is equal to 8. Now when we observe this relation properly, we have one formula. When 0 elements we have, number of subsets are 1. When 1 element we have, number of subsets are 2. When 2 elements we have, number of subsets are 4. When 3 elements we have, number of subsets are 8. Now what is the formula behind these values? Means, now the 1 I can write as 2 power 0. 2 I can write as 2 power 1. 4 I can write as 2 square. 8 I can write as 2 cube. Means all these are nothing but powers of 2. 2 power 0, 2 power 1, 2 power 2 and 2 power 3. So the powers of 2 gives us number of subsets. The powers of 2 gives us number of subsets. Means 2 power 0. How you got 2 power n of A? Means number of elements in set A. How many elements do we have? 0. So 2 power 0. Again here we have a formula 2 power n of A. N of A means number of elements in A. How many elements do we have? Only one element. 2 square. 2 power n of A. Number of elements in set A. Here what we have? 2 power n of A. Number of elements in set A. So finally we have a formula for number of subset. What is the formula for number of subset? 2 power n of A means 2 power number of elements in the given set gives us number of subsets. Now using this formula, let us see one example. Now if set A is having 1, 2, 3, 4 and 5. Set A is having 1, 2, 3, 4, 5 elements. Now I want number of subsets of A. I don't want all the subsets. I want only how many subsets are there. How many subsets are there? There are different questions. For example, we have 30 students in a class. What is the strength of class means? 30. That is enough. For that question, our answer is only 30. Who are they? Who are they? Who are they means we have to list out all the student names. Here, the question is number of subsets of A. I want only a number. I don't want all the subsets. Now, how many subsets do you have? How many subsets do we have in the sense? Now we have to use the formula. What is the formula? So, n of A, number of elements in A is equal to 5. The formula for subset is 2 power n of A, that is equal to 2 power 5, that is equal to 32. Now how many subsets do you have? 32 subsets do you have. If they ask what are they, then you need to list out all the 32 subsets. So this is the way we need to find the number of subsets for a given set, and the formula is 2 power n of A. 2 power n of A. N of A means number of elements in the given set. The concept is power set. So what is the meaning of power set? What is the meaning of power set? Power set, the definition is set of all the subsets, set of all the subsets of a given set. Power set means set of all the subsets of a given set. The definition just you understand. What we are talking about set. How you are getting the set? All the subsets of a given set. For every set we have a few subsets. All the subsets if you consider as a set, that set is nothing but power set. Let me explain one example. Now, set A, I am having the elements 1, 2. Subsets of A. What are the subsets of A we have? As we know that empty set is a subset, set itself is a subset, and individual elements 1 and 2. These are the subsets we have. Now what we are talking? We are talking about power set. Now power set of A. Power set of A. What I told you the definition? Set of all the subsets. Set of all the subsets. What are the subsets do you have? These are the subsets. Power set usually we know P of A is equal to set we are taking. In the set, what are the elements we have means all the subsets. What are the subsets here? 5, A, set 1, set 2. This is nothing but called power set of A. P of A means power set of A. So, what are the elements do you have? All these elements are nothing but subsets of set A. So, all the subsets, if you consider as a set, then you are having a power set. So, power set is nothing but set of all the subsets of a given set. This is the set given. For this set, these are the subsets, and all the subsets when we consider as a set, we have a power set. This is the concept of power set of A.